Welcome everyone. The question that is displayed on the screen, it is said A and B are the two unit vectors. That means its magnitude is unity. Obviously, when you see the unit vector just like I cap, j cap, k cap, or the unit vector of any vector, we use the cap above it. But here we use a vectors notation, that is the arrow sign. Mostly the hat signs are used, but here the arrow signs are used. Okay, but it does not making difference. Basically all of these are notations. Here is the arrow signs, but we can consider these as the unit vectors. This magnitude is unity if anywhere it is required, and these two unit vectors are making the angle alpha and beta with the positive x-axis. Okay, so prove that the trigonometric relations, the trigonometric identity you need to prove here, that is cos alpha minus beta equal to cos alpha cos beta plus sin alpha sin beta. So let me draw the two-dimensional axis. Let us say this is my two-dimensional axis and this is the x-axis and this is the y-axis. Okay, now let us say this is the b vector, this is the b vector, and let us say this is my a vector, this is my a vector. Both are the unit vectors. Angle of the a vector with the x-axis is alpha, angle of the b vector with the x-axis is beta. Okay, so in this particular cases, if I want to write down what is the a vector, okay, what is the a vector, then I have to write it down like this. I will remove it later. That is, this is the ax, okay, this is ax and this is ay. Okay, so this is ay. So we can say that is the a vector is basically the axi cap plus ayj cap. And what is this ax? Ax is a cos alpha. This is a cos alpha I cap, and ay is a sin alpha j cap. Okay, now if you want to represent the v vector, similarly we can write it down in terms of its x component and y component. We can say this is the bx I cap plus by j cap. So this will become b cos alpha I cap plus of b sin alpha j cap. So now if I do the dot product, okay, if I do the dot product, then according to the rule of the dot product, a dot b should be equal to the magnitude of a, okay, the magnitude of a, the magnitude of b, okay, after that the angle between the a vector and the b vector. And we can see from the figure, this is nothing but alpha minus beta. So we can say this is alpha minus beta. So we can write it down like this way, that is a dot b. A is a cos alpha dot b cos alpha. So we can say it is a cos alpha I cap with I cap. One mistake we have done here, this is not the alpha, this is the beta, because the b vector, please correct it, b vector makes an angle beta with the x-axis. So after that a cos alpha b cos beta, okay, multiplying the I cap with I cap, and again multiplying the j cap with j cap, that means the two y component of the a vector, y component of the a vector multiplied by the y component of the b vector. Okay, so this is the value of a dot b, and this is mod of a, this is mod of b, and this is cos alpha minus of beta. Okay, so this is becomes ab. If I take common, then it becomes cos alpha cos beta plus sin alpha sin beta. This is AB cos alpha minus beta. Okay, alpha minus beta. So AB cancels out. We know that the AB are the two unit vectors. If A have some values, just let it be, because it is cancelling out from the both sides. Okay, so this will become cos alpha minus beta, the trigonometric identity, equal to cos alpha cos beta plus of sin alpha sin beta. So this trigonometric identity is proved from the concept of the component, perpendicular components of the vectors, and the concept of the dot product. Thank you all of you.